Hi everyone, welcome to another community call. I see it's already live in the chat, so hi everyone, feel free to chat away and yeah, looking forward to this one. I'm Mata from the DX team here in Memgraph, and today I'm joined by Memgraph CTO Marko Budisilic, better known as Buddha in our circles. But yeah, Buddha, it's great to have you here again. In today's session, Buddha will introduce Atomic GraphRAG and show how to move from basic search to powerful graph-based retrieval and generation in one simple unified step. So besides this call today, we also have few more upcoming CCs or community calls in the next weeks. So I'll make sure to post links in the chat so you can register to those as well. And yeah, as already said, we have a chat open, so feel free to drop your questions there as we go. And we'll make sure to leave some space for them at the end of the call, so we have a short Q&A session. But yeah, I guess that's it. With that, I'll hand it over to you, Buddha.
Thank you, Matea. Hello, everyone. Welcome to the community call. Chat is already on fire, so that's good. Please ask, as I go through, please ask questions. We'll try to answer. And yeah, the topic of today's call is Atomic GraphRAG, a single unified GraphRAG execution layer. We'll try to present the whole idea and how does it play in the broader AI ecosystem. First, just to make a quick introduction, I'm Marko, co-founder and CTO at Memgraph, mostly working on the product side of Memgraph, figuring out all the initiatives and what features to build and how to fix all the bugs and how to make sure Memgraph works as a product in the best possible way. So before diving in, quick introduction. So we're going to talk about Atomic GraphRAG, but before that, all the efforts here are based on the previous efforts and what we built. So please check out our blog, documentation. There is a lot of resources there. There is also AI toolkit on GitHub, which has a bunch of interesting tools to play with. And also there is unstructured to graph. Part of this here was built by unstructured to graph, so definitely something to check out if you want to take unstructured data and turn that into graphs. And also Ante did a community call last week about agent skills. This is also part of the whole Atomic GraphRAG thing, and that's available on YouTube. So check out that at some point. And also, we just launched a few days ago the Memgraph skills on GitHub as well. So the idea there is to build various different skills that Memgraph users can use to do different things, build query modules, any operational stuff, whatever helps with Memgraph from the user perspective. Yeah, highly recommending all those resources. Please go and check them out. Before Atomic GraphRAG, so a quick intro about Memgraph. So Memgraph is in-memory high-performance graph database, super optimized for context engine for AI, both for retrieval and memory layers with structured and explainable context. So we are trying to position Memgraph as AI context engine, where the idea is to fetch data from various different data sources and figure out what's the right context for AI. A few days ago, we actually published Memgraph 3.8, which was the single biggest stable release so far. Part of the release, on a high level, I would say there are two main benefits. One is that it's drastically faster because of parallel execution, or also known as intra-query parallelization feature. So that was introduced inside Memgraph. And also concurrent edge writes. We finally managed to figure out how to avoid serialization errors on writes while keeping the ACID guarantees in the database engine. So all these workloads which need parallel ingestion of edges now are much better. and also lower cost because there is a feature called single store vector search. Basically, all these vectors and embeddings needed to perform vector search are now stored only inside index, which is essentially optimized way to store index in our case, because previously we needed to store vectors twice, in the primary storage and also in the index, and that wasn't optimized. And now, because of that, let's say, optimization, we can I mean, the storage overhead in certain workloads was reduced to like reduced for 80%, and that's a significant gain. There is also the allowed CSV JSON-L parquet, basically various different formats directly from the local file or HTTPS or S3. That's really interesting because it allows on-demand use cases for Memgraph, where the data is pulled on demand, and then some analytics could be run, and in the end you just discard the whole Memgraph instance and you can move on. Basically, it's also very suitable for agentic workloads because you can just have database instance running when it's needed for an agent. Those are the most relevant stuff. There is also a bunch of other stuff. It's available on to check out in the changelog. But topic for today's call is Atomic GraphRAG, and let's dive straight in. So technical definition of Atomic GraphRAG is that's a set of tools and primitives that enables building GraphRAG pipelines as one queries, as single queries. Essentially, that's a list of different things in the engine. For example, real-time schema info or show schema info query, which is used to retrieve the schema or ontology of the graph. There are also embeddings procedures, text and node sentence, where you can calculate embedding based on a text or the whole node can be used as to calculate embeddings. So you can search for the text on that node during the vector search phase. There are also vector search and text search features. Also, all graph algorithms are basically there, like deep path traversals, community detection, PageRank. LLM complete function. Basically, it's possible to call LLM directly from Memgraph to complete a text. And also server-side params. That's still in the workings, but it's going to be available in the next few days under daily builds, and it's going to be part of the 3.9 release. Basically, that's very useful for like centralizing the config, but I'll explain that a bit later. So far, we had a definition of a GraphRAG, which was basically something like this. If there is a user question, that against that question pivot search was done, and then based on the retrieve nodes, relevance expansion was done by some deep path traversal algorithm, basically searching for connected nodes, and then based on all that, in the end, that was put in the context, and then the answer was generated. Of course, you needed the data modeling part to actually figure out the graph in the first place, and basically, that was the, let's say, canonical example of a GraphRAG. But in the last few, let's say, two years or so, in all the workloads we saw, basically there are three types of questions. One, I call those questions analytical, where in order to fetch the relevant data, it's required to perform some database query, let's say some analytical type of query, to count something or to deterministically figure out information from the data, and that's where usually you have to execute some basic database query. Then there is also a so-called like local type of question, where a small subset of a graph or a small subset of a dataset has to be retrieved in order to fill in the context and figure out the answer. That's basically like you have to find something relevant and then try to find connected edges and then return that. And then there is also the global question, which is kind of similar to analytical, but it's usually much broader. So you have to analyze all the text data in your text dataset somehow, or I don't know, take the whole dataset into account in some advanced way, basically give some summaries or something. And then based on that, the whole, the final answer is generated. And basically, based on those three questions, we define three main atomic GraphRAG pipelines. The image from before looks a bit more complex now. Basically, depending on the question type, let's say, like the whole runtime, let's call it agentic runtime, basically something like Claude Code or Cursor or Memgraph Lab will figure out or will run LLM, and basically the pipeline type will be determined. Let's say if there is analytical question, usually it's very wise to run some kind of text to cipher. And in order to do that, you first have to get the schema out, and then based on the schema, cipher can be generated and executed. For the local type of question, we have the pipeline from before. Now that's called GraphRAG search, where we do pivot search first, text search or vector search, depending on the question again. And then we do relevance expansion, which can be BFS or DFS or some other traversal algorithm. And then ranking in the end, because you have certain amount of nodes which are hit. And the question is, what are the most relevant ones? The ranking could be like many different things. For example, basic node degree or page rank or some other way. We also debated at some point using LLM to actually rank the given nodes, but that's quite expensive in terms of time. So basically, it's possible to tweak how the ranking looks like. And then for the global type of question, that's what's called that pipeline is called query focused summarization, or Microsoft GraphRAG, what was defined like even maybe 2 years ago. And in that pipeline, basically the goal is to first group nodes into some kind of communities, usually community detection algorithm like Louvain is called. And then for each community, there are summaries which are generated. Basically, you take all the members of the community and generate a summary for that community. And then for the question which came in, each community is evaluated against that question, and based on all these, let's say, partial results, partial evals, at the end you ask LLM to answer the question based on all these, based on the initial question and all these partial results. And by doing that, you get an answer for that global type of question. Again, it's still possible. It's still required to do data modeling and figure out how the graphs look like. But it's also possible to pull data with various other from various other sources. Let's say public web. I have that actually in the example later on. And yeah, those are, let's say, 3 typical atomic GraphRAG pipelines, and all of that is orchestrated by agentic runtime. So you need some kind of a agentic loop, let's say, even though I call I like more the agentic runtime name because it has more than just a simple loop. You need some kind of a runtime to actually drive that whole process and iterate against multiple, run multiple attempts to actually figure out the answer. These are, let's say, some basic types of pipelines, but what happens in reality is that for a given question, agentic runtime will actually try to do many different things, and it might pick and choose what actually is executed. Essentially, it's going to execute these atomic queries, more of them, depending on the progress in the agentic loop. And it's also possible to do different combinations. So, for example, there can be a case where show schema info is run. That's usually very smart to do in any case, except when you have like super large schema or it's obvious that you have to do some kind of vector search. But schema is very smart first step, and then after schema you can run some cipher, but then you can go back to pivot search and relevance expansion and ranking. But in reality, you can like that whole thing, that whole pipeline, that whole agent can run for a while and figure out different things until it figures out the best thing for the context. Okay, just a question. So there is, I guess we'll answer the question in the end, or yeah, we'll keep that for the end. Okay, so what does that mean from the benefit perspective? So Atomic GraphRAG is kind of a bridge between agentic runtime and the database over MCP, because if there are those let's say pipelines which are atomic, where you can pack more things together, it's actually possible to make many different steps without any generating some code or even like add additional code or do a lot of extra steps to actually figure out how to execute something, how to communicate with the database or something else. Basically, like hypothesis is that agentic runtime plus skills plus MCP and Atomic GraphRAG is all you need. And I actually have an example on that side. Why is that so? But basically, with those four, it's possible to do very advanced pipelines and answer very advanced questions. Maybe to put that into a visualization, basically, agentic runtime on the bottom has those components like skills, prompts, subagents, and projects. And then to communicate with the data, what by default happens is that agentic runtime will generate, or LLM will generate, some imperative code. But the problem there is that it's kind of big. It has to be reviewed, and it's not super optimal, and it doesn't work. It has a bunch of problems. In the first place, you have to make it work somehow. A better case is to generate some CLI command line interface tool call, like for example MG console, or GitHub CLI or such things, where you have some kind of interface to actually interact with underlying data. That's slightly better because there is no much code to review, but it still takes a bit of the context because kind of the whole agentic runtime has to be aware of the tool itself. Some of those tools can be learned. I mean, during the LLM training process, the tool, like the tool usage, can be learned. But that's not the case for all the tools, and tools change, and you have a bunch of problems there over time. And then the best case is actually if you can just run atomic database queries, is to use MCP, because MCP is very standardized. Wherever LLM has to call something in a structured way, MCP from the LLM perspective, if you take like perspective of LLM, is the best thing, because you have tools, and with a few tools you can actually interact with the system. In the database case, you just need basically run query tool, and then you execute those advanced queries through MCP, and that's very efficient from an LLM perspective. To be a bit more concrete on the example side, basically on the left there is a Python code used to generate communities. Community summaries based on graph communities, and it's quite a big script to actually to make it done, because you have to prepare all the code, you have to fetch the communities, you have to generate the summaries, you have to call LLM, you have to connect those communities to newly created nodes, and that's a multiple step process, which takes some code in Python. And on the right, there is like a single cipher statement, which is doing all of that. Basically, running LLM, generating community nodes, attaching those nodes to existing nodes in the graph, and all of that is done atomically and in a small query. And then, like, the runtime can actually execute that through MCP, and that's it. No extra code is needed to be generated and then discarded later on. In this particular example, there is like a 10x difference in terms of the code that has to be managed. So 10x less code or more. And why is that critical? Because humans have to review much less code, meaning that there is much faster feedback loop. Essentially, there is no need to review that code. And I mean, you still have to review the generated cipher queries, but Python can be much bigger. And also dependencies have to be properly configured, and the whole thing can fail when running it, and that's all like a pretty big mess. And then also it's important to keep context windows smaller, because there is less hallucination, there is more accuracy, and there is, in general, that whole process is faster and cheaper to execute. And yeah, it's just if you can deal with smaller context, that's always better from the LLM perspective. And then even on a bit higher level, who here knows what's Kardashev scale? So for those who don't, that's like a physics concept which says how much energy a given civilization can harness. And basically, there are different types of civilizations. Basically, if a civilization can harness the whole energy on planet Earth, that's like type 1 civilization. And then if you can harness the energy of the whole solar system, that's type 2. And then the whole galaxy, that's type 3. And basically, the whole LLMs plus Atomic GraphRAG, it's kind of reminding me of Kardashev scale, but for data. Because with those things combined, it's possible to perform all these tasks, and basically any given role. Any given role will is getting much better because you can process much more data. And we kind of feels like with all these tooling in place, kind of feels to me that we definitely moved up on the scale. Yeah. Okay. So in terms of practical things, how to put that into reality, how to put that into play. Basically, I think there is a blueprint for how to perform a GraphRAG for each question type. So depending on the type, I mean, at the moment we have those 3, but I think more types are possible. You have different questions you can ask. And so for each of the question type, there has to be a blueprint how to actually perform that against the data. And then for each specific role, like data analyst, lawyer, accountant, product manager, one should build like a concrete agent skill that will basically have examples of those queries, basically nudge LLM in the right direction, and give all the examples which are relevant. And once you have those skills, LLM can actually, because when agent is started, it's starting from scratch. It's starting from 0, but has a pretty good foundation to actually compose different queries to answer various questions, or do some tasks. And I mean, under the hood, graphs can be used to store data, but also store any process information or events, so-called the context graph. So in addition to just basic data, you can also have process data or any other data in the system, and based on that, you can also derive knowledge. For example, you can store previous interactions and use that to actually improve the skills or improve the processes itself. And to get even more real, so basically, as a product manager at Memgraph, I decided to dog food a bit the whole product management thing. And basically, I took data from GitHub about issues. So there is more than 500 issues about Memgraph at this point. And they are labeled with different labels, and there is some other data attached. Basically, I pulled all that into Memgraph and built those related to relationships between issues. So basically, I used unstructured to graph to extract entities from descriptions and titles, and based on those entities, different issues are connected. So you can connect different issues just based on the common entities between them. And that's the graph on the right. Basically, we have some issues, and they are connected with entities in between. Once you have those related to issues, because related to edges, they connect similar nodes, let's say issues, and it's actually possible to compute communities of those issues and then run summaries. And that's how the whole graph looks like. So the bigger nodes are community nodes, which hold those summaries, and then the different colors are representing the communities. The same color node belongs into the same community, and based on that, you can run query focused summarization and such things. So, and then once that data is in place, there is actually a product management skill which has all these Atomic GraphRAG examples, different examples of how to perform GraphRAG, and then that can be used inside agentic runtime to answer various product management questions. Basically, in my case, I used a cursor agent to actually run the agentic runtime and then ask various questions. So to give an example of the question, so analytical question is, I came up with a pretty basic one. How many feature requests Memgraph has, and basically for that question, the agent generated show schema info query, and then one shot type of thing. It found issue, and issues have issue type property, and there is a analytical query against that property, and counts are represented here in the table. And this is actually, we actually have a bug in the system because we have we use labels and issue type. That's a specific field on each issue. So the count could be better, but that's purely because of the data modeling. So we have to fix that data modeling part, and then it should be right. But the answer based on the data is correct. That was a pretty simple example. This one is a bit more interesting. Basically, I mentioned that concurrent serialization error problem, which was fixed in one of the PRs. But then the question is, what are the related issues which should be closed or updated, and to who we should communicate the fix from the community? And that's much more advanced question. And for that thing, the agent first pull data from GitHub, because there is a PR. PR wasn't part of the data set inside Memgraph. And then based on that, it actually generated like text search call, calculate embeddings, do the vector search, also run a relevance expansion against that. It generated the query to run a relevance expansion, and then also run some show schema info and some regular, let's say, Memgraph queries fetching. It used, for example, the regex search in certain cases to find a relevant node. And then it also pulled from, it was interesting because it also pulled data about authors on GitHub, because that wasn't part of the dataset. Again, I have to extend the dataset. And in this case, it was nice because the data was already public. So GitHub, like the GitHub CLI, could pull some missing data if that data is small. Let's say authors, it's easy at the end to pull data about authors of different PRs. And then the result surprised me a bit, because first issue was just internal issue to actually resolve that problem, and that's there is no action to that. But then the rest four are really interesting, because basically this is like a community member which asked when there is, which reported a bug like 6 months ago, exactly on the concurrent edge path related to triggers. And because there is no more serialization errors on edges, probably that's resolved, and that should be updated and I mean retested and updated. But we probably solved that issue. And then those two are one is just fixing the error message. That's easy but related, and the other one was concurrent node serialization error. It's not 100%, but it's slightly related. But there is no, like, there is just update needed and no action. And then the last one was really interesting, because it wasn't like a serialization error. It was a bug on edge import. And because we changed a lot of code in the meantime, it is more than a year old issue. Probably that one is resolved and should be closed. But again, we should retest and see if it's happening. But yeah, without this type of results, it would be super hard to find those issues, because they happened way back, and it's very hard to keep track of like 500 issues on GitHub. You need some kind of engine like this to actually give you relevant issues. And then the last type of question was broad type of question. For example, where are memgraphs blind spots? And for that question is to answer that question, you have to like analyze a bunch of text, a bunch of data under all of those issues, and basically this query is just calculating all the partial answers for each community which is present in the graph, and then assembling the final question, the final answer based on all the partial results. And so the communities were calculated by using community detection Louvain algorithm. And then the summaries, I used GPT-5 mini to get the summaries and to get the answers. And in the end, the answer was, I mean, much bigger than this, but this is the most important part. So it kind of LLM isolated a few most important areas. And because those are mostly like issues and bugs about Memgraph, first one is obvious, correctness and crash risks. And that's the highest priority thing to focus on. But the second and third is really interesting, because, and we are actually doing that, because in a lot of customer workloads, we have various planner inefficiencies that we have to fix. But I haven't thinking that we will, by fixing the planner, we can actually resolve, and we'll probably improve massively all these issues and all these problems. I mean, probably not all, but a lot of them will be significantly improved once we finish the current effort figuring out the planner. And then, yeah, memory safety and observability. Like there are a few, when you look at the data, there are a few of those which are quite big and which have to be fixed. But anyway, this is like a quite accurate result, and I hope I didn't add any bias in the result. But yeah, it's nice to get like broader overview of what types of issues we have. And then in terms of the future, how that will evolve in the future. So I already mentioned server-side parameters that will come very soon. It's a big thing because it will allow even shorter queries. There is also ability to centralize config, and that's actually how we started the whole thing, because basically when vector search is created or when embeddings are calculated, those two things have to share the same config. For example, the size of an embedding or the size of a vector search, it's called dimension of the vector search index. Those things have to be the same. And then if you centralize, you have to centralize the config to make sure that the config is the same. And then also client implementation will be simpler because you can just reference one centralized config instead of like just constantly calling constantly passing config and make sure it has to be correct. And that we're going to use that in Memgraph Lab to actually make sure that and allow better implementation and easier implementation of such calls. Also, something called automatic embeddings is interesting. Basically, that's like having more and better embeddings off the shelf. Because embeddings are a really important part to actually search the initial nodes, and we'll try to improve that from the user perspective. There is also composable show schema info, basically enable schema filtering in the same query, because sometimes schema is quite large and it can't fit under the context window. So we want to be able to compose some other filtering or something after the show schema info, so that you can actually cut the schema out or do something else. Who knows what else is possible? Probably LLM will come with really interesting examples how to actually run that. And then also graph neural networks are very interesting. Basically support for Python geometric and TensorFlow GNN, because GNNs could be used to run ranking and also do some predictions during those pipelines. Probably ranking is the obvious case, but yeah, we'll see. Maybe something else like link prediction can be used to answer certain questions when you more look for some interesting connections between different nodes. And then last but not least, so Memgraph Lab already has some agentic runtime capabilities, like Graph Chat is already agentic loop where you can ask questions and get some results back. But the idea is to deeply integrate skills and all the things needed to actually perform like the whole pipeline. Basically, these four things: agentic runtime, MCP, skills, and Atomic GraphRAG. And the plan is to integrate all of that deeply, so it's very easy from the lab to do all of those things once you have the graph done. And yeah. Just to wrap up, so how to get started, you can pull Memgraph MAGE image, which has all of those things packaged, or you can just run Memgraph under the cloud, have fun with Atomic GraphRAG, and please sign up for office hours to chat more for specific questions or anything, any topic you would like to discuss. And then also for enterprises, there is the Jumpstart program. Basically, we are trying to run 2 weeks POCs for GraphRAG, helping building different pipelines and helping prove the value of a GraphRAG. If interested, please register at memgraph.com/GraphRAG. And that's it. If you have any question, also you can reach out to me directly or join our Discord community. There is a bunch of stuff happening there, so yeah, please join. And yeah, that's it. Thank you for listening. I hope I saw some questions. Maybe we can answer that.
Yep. Thank you, Burak, for the presentation. This was great. And we do have some questions from the audience already. So the first question is from the user Luca, asking how is this compared to ArcadeDB, if you're familiar with that?
Can I stop sharing Arcade? I think I heard about them, but I don't know out of my, here is the, I'll just, ArcadeDB. I think I know them. That's the Arcade Analytics, the company from before. Uh, uh Yeah, I'm not sure exactly what are they doing on the GraphRAG side. Seems like they do multimodal. So I mean, I guess they even do more on the whole multimodal side and various different formats. For example, key value store and time series data. But yeah, Memgraph is more focused on the graph side. So figuring out all the graph analytics and modeling data as a graph and being super performant and real time on the graph side. And also, yeah, we are trying to package all of that Atomic GraphRAG and all the other things to have like a built-in solution for to solve all these things to essentially run everything from a single UI like Memgraph Lab. So I'm not sure if they do something like that, but yeah, fully like vertically integrated solution for a GraphRAG, let's say. That's what we are trying to be really focused on right now. If that makes sense.
Yeah, thank you. So another question, Aaron asked, or he said that he had issues with text decipher hallucinations, where the model makes up nodes or relationships that don't exist. Have you tried using constraint decoding to force the model to stay within the actual database schema?
Yeah, I haven't actually tried the constraint decoding to enforce. Yeah, I guess for some like advanced uh, like questions, probably that's a problem. Or let's say if the schema is too big, so if there is a lot of schema to handle, probably that can like LLM can go out and hallucinate. I'm not sure what's the main reason for hallucination, but yeah, even that, or maybe also we were thinking but once the show schema info becomes composable, then also it's possible to perform like GraphRAG on the schema graph to actually nail down the relevant nodes, and then yeah, you just instruct LM to actually not hallucinate there, or like try to pick exactly what's in the schema and not go beyond that. But yeah, I haven't tried that approach yet, so not sure how that would work.
Yeah, and the user commented that maybe the composable schema show info would help the agentic runtime.
Yeah, for sure, because it's a problem. I mean, if you have like a very well defined graph already, basically, I don't know, cybersecurity graph or something, some IT infrastructure graph, that's okay because the schema is relatively small. But for example, with those unstructured to graph, with entity graph, there is a lot of entities and a lot of schema components, and that can be huge. And then show schema and info has to be controlled in a much better way.
Yeah, okay, that makes sense. So next question is, how are the credentials managed? So if we have four environment variables, I want to compare data integrity across for all queuing person use case would be really good to know.
Uh-huh. So yeah, that's also a point I didn't make with the schema. Sorry, with the with all the Atomic GraphRAG because no extra code is needed to be generated, and then it's a bit easier because there is less components. I guess it's a bit easier to control the security aspects. But I guess the answer is like MCP has some security stack to actually handle, and then also like classic label-based access control rules. I mean, the graph has to be controlled in a way that only certain people have access to a certain parts of the graph and stuff like that. So by using clause-based or label-based access control, it's possible to control who sees what, and that will be enforced if you are running queries against Memgraph. That can be enforced.
Yeah, okay. And how does Atomic GraphRAG compare to using Neo4j query functions?
The question is, what are the query functions? I mean, probably like the whole Atomic GraphRAG is again set of tools. So we have few. I think Neo doesn't do server-side params. I haven't seen that there. But other things, and I know about embeddings, for example, those embeddings could be calculated on the GPU and stuff like that. The Memgraph has the CUDA image, and these are just different tools which are available. I mean, you can Atomic. You can also execute Atomic queries against Neo and compose those things. Not sure if they can do embeddings and then compose that with vector search. If that's possible, that's one example that will work. But again, my point was more on the presentation about whole that stack, because once you have those Atomic queries, you only need MCP to actually, I mean, you only need LLM and then MCP to pass that data to pass the query to the database, and that's it. Like, you will get the results out, and the process can be multi-step, so different things can be generated. But yeah, I'm not sure about query functions. I guess I think you refer to the actual functions in the Cypher, which is, I mean, Cypher has procedures and functions, and then functions can be called inside the expression. So, for example, LLM complete is a function currently, so that's the same as Neo4j query function, if that's the feature you're talking about. And then yeah, basically these functions are just part of the queries. For example, LLM complete is super critical to actually, if LLM is needed to do something server side, then that function is critical to actually perform that. Yeah, I'm not sure. Functions. Yeah, I can only, when I Google, I can only find like functions in Cypher. So essentially, that's those are functions, and functions are part of the Atomic GraphRAG. So certain functions are really important. For example, embeddings. So, embedding is a procedure, but let's say embeddings is a procedure. Functions, LLM call is a function, and some other functions will be there, part of that pipeline. In certain cases, it's very useful to have them.
Yeah, we have a few questions related to comparisons. So the next question is a comparison with HelixDB, so basically the same as the comparison with ArcadeDB.
Yeah, I heard about them as well, but they seems to be a bit more on the vector side, or yeah, basically they're a relatively new player. Not sure again what do they offer on the GraphRAG side. But yeah, because they mentioned it's GraphRAG and vector search, I guess that's also, I mean, for the GraphRAG search, that pivot search and relevance expansion, I think you can do that. But as far as I see, it's not Cypher. They have some other query language. It's a different stack. So yeah, basically, yeah, the biggest difference outside is the support for Cypher, and then Memgraph and Neo are the biggest implementers of Cypher, so it's a huge compatibility there. But yeah, not sure under the hood how Helix does various things, and what's the ecosystem around. So the question is also, with Cypher and Bolt, there is a huge ecosystem of tools available you can use to visualize data, to I don't know, do different things. There is plenty of, for MCP for sure. There is multiple MCP implementations for Bolt and stuff like that.
Yeah. And one more question from Mohammed. So what about the GLiner 2 model for entity extraction, JSON schema building and formatting? All that in one pass, would it be interesting to use with Memgraph?
Yeah. So I haven't tried that model for entity extraction, but when I was working with unstructured to graph, I tried out many different things. So I tried out LLMs. I tried the NLTK kit to extract entities. I've built a few different pipelines to extract entities, but my conclusion was that LLM, like large LLM models, work the best for entity extraction by far. I mean, on some simple texts, it's maybe okay to run some simpler models, but for complex texts, let's say legal or accounting text, like LLMs are by far the best in extracting entities. At least that's my opinion. That's my result. So mostly I use that for entity extraction. But I don't know about that model in particular. We'll check it out, and then see if it gets some good numbers. But yeah, it's a trade-off between accuracy and the cost and the speed. So generating a graph from unstructured text is quite heavy on the LLM side. I think it can be optimized, and there is a bunch of stuff possible there. But yeah, any entity extraction model which can work, or which works, I actually think the cost and time is important criteria. So if it can be run fast, that would be amazing. And then the JSON schema building and formatting. I'm not sure about of what, but JSON schema. I mean, show schema info in SkyDA in the JSON format. So maybe from unstructured to graph, if there is like a tool that will produce the JSON schema of that may be interesting. But yeah, I think like on the schema extraction thing, I think you can't define upfront the schema because you don't know what are the entities in the graph in the text. You have to start building entities, but then later on you have to reconcile, and you have to like see what are the relevant entities and what's useful for your use case. So somehow that has to be also interactive process. Once you start building the graph of entities, then you go back and reconcile. And again, that can be human reviewed, but also there can be agentic loop that does that reconciliation loop for sure. But anyway, that's maybe a different question. So I don't know. We'll check out that model. A lot of things to check out.
I think that's all of the questions. If I didn't miss any, hopefully I didn't. But yeah, we can give it another minute or two if somebody has another question. Yeah, we have some comments in the chat.
Yeah, deriving the what is that model?
Yeah.
Can we get the expert? Can we get the expert of those questions and the text, the chat in general, just to follow?
I think the chat remains here when the recording is available, so we'll have it on Crowdcast hopefully. I haven't checked it out, but I think there should be. But yeah, I guess that's it. Thank you again, Buddha, for the great call. The recording will be available on Memgraph's on-demand page. I'm going to post a link in the chat so you have that here as well. It will be available in a few days, so keep an eye on it. So if you're experimenting with GraphRAG, Atomic GraphRAG, or Memgraph in general, feel free to join our Discord server. Already shared a link somewhere here. It got lost in all of the comments in the chat. But yeah, we constantly hang out there, so feel free to join and let us know about the projects you're working on. And yeah, hope you have a great rest of the day, and I'll see you at our next community call. Bye, guys.
Thank you. Take care. Bye-bye.
Bye-bye.